Hello everyone, I am Dr. Haseen Ahmed and you are watching Chemistry with Dr. Yousafzai YouTube channel. Yesterday we discussed Beckmann rearrangement reaction. In case of Beckmann rearrangement reaction, oxime will react with acid, so it is converted into amide. What type of amide? Let's suppose this is R2 and carbonyl functionality and here NH R1. So such type of amide is produced as a result of Beckmann rearrangement reaction in the presence of acid. But in some of the cases, when oxime react with acid, it is not converted into amide, but the final product in this case is nitrile. So such type of reaction is known as abnormal Beckmann rearrangement reaction, in which amide is not formed, but instead of amide, nitrile is the final product. So how this reaction takes place? Let's have a look to the reaction mechanism. When oxime react with acid, so it is converted into OH2 plus, here R2 and here it is R1. If we talk about this OH2 group with positive charge species, it is unstable. So due to this reason, the bond between nitrogen and oxygen, this bond, so it will be break toward oxygen atom. So both of the bonding electron will move on oxygen atom. So due to this reason, what type of charge will appear on nitrogen? So nitrogen will get positive charge. This is R2 and this is R1. So in case of normal Beckmann rearrangement reaction, one of the alkyl group migrate to nitrogen atom, and in this case both of the bonding electron between carbon and this alkyl group will migrate to nitrogen atom. So this alkyl group takes both of the bonding electron to the nitrogen atom, and as a result what will happen, it is R2 carbon nitrogen with double bond, and here it is R1. So positive charge will be appeared on this carbon atom. As we discussed already in the normal Beckmann rearrangement reaction, that water molecule is present in the reaction mixture. So when water molecule is present in the reaction mixture, from where this water molecule comes, it is resulted in the formation of dehydration reaction. So in case of dehydration reaction, water molecule is produced. So this water molecule attack on this carbonyl position, and as a result it is converted into amide. But in case of uh, this type of or abnormal rearrangement reaction, when this carbonyl is produced, so what will happen? From here, it is nitrogen with lone pair of electron is shifted toward this carbon atom, and as a result this intermediate is produced. So this intermediate is produced. So now this is the main step for the abnormal rearrangement reaction or Beckmann rearrangement reaction, in which this bond between nitrogen and alkyl group breaks toward nitrogen atom, and as a result nitrile is produced as the final product with the removal of carbonyl species. So it is nitrile species is produced in such type of abnormal Beckmann rearrangement reaction. So let's have a look to some of the example in which abnormal Beckmann rearrangement reaction takes place. Let's have a look here. It is oxime. So when this type of oxime react with acid or proton, so proton will gain by this OH of oxime, and it will be converted into OH2 plus charge, and now what will happen? So it will be removed in the form of water molecule. So dehydration reaction takes place, and here, as we already talked about, that nitrogen will get positive charge. So here nitrogen with positive charge species. So in the next step what will happen, this alkyl group will move on the nitrogen atom and the bond will be break towards this carbon atom. So what will happen? So it will move like this, and here both of the bonding electron will be moved from this carbon atom, and as a result positive charge will be appeared on this carbon atom. So another carbanion is produced, or tertiary carbanion is produced here. So in the next step, here methyl group is present. So from one of the hydrogen atom from methyl will be removed in the form of proton. So one of the hydrogen atom will be removed in the form of proton. So as a result of this, alkene will be the final product. So here nitrile is produced instead of amide, which is the product of abnormal Beckmann rearrangement reaction. And here is another example of such type of abnormal Beckmann rearrangement reaction. In the previous example, if we look at the previous example here, protic acid is used, and in the next example, here Lewis acid is used. As we already talked about in the Beckmann rearrangement reaction, that in case of Beckmann rearrangement reaction, both type of acid is feasible for the reaction. That if we use protic acid or Lewis acid, in both of these cases Beckmann rearrangement reaction is feasible. So in this example here PCl5 Lewis acid is used, and in this case OH of oxime will attack on phosphorus of PCl5, and one of the chlorine atom will be removed in the form of chloride ion, which will abstract this hydrogen atom, and HCl will be removed. So when HCl is removed, then what will happen? One of the bond, this bond will break and will attack on this nitrogen atom, and as a result triple bond will be formed between carbon and nitrogen atom, and POCl3 will be removed. So in this case, the carbanion or tertiary carbanion is produced, as we already discussed, that it is CH3 group. So one of the hydrogen atom will be removed in the form of proton, and as a result, a double bond will be produced, or alkene will be produced here. So there are different chances that which type of alkene will be feasible for such type of reaction. It may be exocyclic double bond or alkene, or it may be internal alkene, and this is also internal alkene. In case of external double bond, the yield is 75%, or 75% of the product is external alkene, whereas internal alkene it is of 11%. So this is the abnormal Beckmann rearrangement reaction, and if you have any type of question, you may ask in the comment section. Thank you so much. The Allah Paman.